All right, for homework number 19, we are practicing our antiderivatives. So this first question says, verify the statement by showing that the derivative of the right side equals the integrand of the left side. So remember, the integrand is this thing. So they're asking me to show that the derivative with respect to x of the right side of the equation, let's make that 2x to the negative third, plus c. They're asking me to show that that equals the integrand, which is negative 6 over x to the fourth. You don't have to write the dx part. The integrand is just what's in parentheses there. All right, so, well, actually, I guess the dx part is part of the integrand, but whatever. We're just showing this part. Okay, so if we take this derivative, we get negative 6x to the negative fourth plus 0. And yeah, that's negative 6 over x to the fourth. So it's not like a super long proof or anything. I'm going to use my little box to show that I've done that. But yeah, we're just showing that you can check. Basically, this is trying to get across the point that you can check your answers. Whatever you got here, if you take its derivative, you should get the integrand. Same thing here. We're trying to show that the derivative with respect to x of this left side of the equation is equal to what we get on the right side of the equation. Oops, wait. I just wrote that backwards. Sorry. We're trying to show, other way, trying to show the derivative of this. Goodness, I'll get there. The derivative of that is equal to, here we go, x squared minus 1 over x to the 3 halves. So before we take this derivative, let's clean up the inside a bit. So this is 2x squared plus 6. I want to divide each term because taking derivatives, I want to divide each term by the single value instead of doing a quotient rule. So 2x squared divided by 3x to the 1 half is 2/3. And then 2 minus 1 half is x to the 3 halves. And then 6 divided by 3 is plus 2. And instead of over radical x, I'm going to say x to the negative 1 half. So that's just me making this easier to take the derivative of. Okay, and then take the derivative. So 2/3 times 3 halves is 1. X to the subtract 1 or subtract 2 over 2, so x to the 1 half. Minus 2 times negative 1 half, that's why I put a minus there, is 1. X to the subtract 1, negative 3 halves. Derivative of c, a constant, is just 0. All right, and then how am I supposed to get this? So all they've done here is rewrite, all they've done here is rewrite to get a common denominator. So I could show this. And then, yeah, what do I do to get a common denominator? I multiply this by x to the 3 halves over x to the 3 halves. So adding my exponents here, x to the 4 halves is where the x squared comes from, minus 1. And since they have a common denominator, I can put it all over x to the 3 halves. And that equals the integrand, which was what I set on the other side of the equation. So that has been proven as well. Okay, complete the table. So first, rewrite if necessary. So just like we did with derivatives, it's a good idea to rewrite roots in their exponential form since you're using an exponent rule here. Integrate, so the rule is to add 1 to the exponent. Add 1 to the exponent. So if I add 3 over 3, I get x to the 4/3 divided by that new exponent, divided by 4/3, plus c. Simplify, meaning we're not going to leave this like this. It looks terrible. So it's instead of divided by 4/3, it's 3/4 times x to the 4/3 plus c. I want to rewrite number 11. X times x is x to the first times x to the 1 half. So x to the 3 halves in the denominator. So let's rewrite this as the integral of x to the negative 3 halves dx. I'm going to stress this early on, but you have to write the dx in your integral. Otherwise, when you're writing integrands for the AP test, they won't give you credit if you don't have the dx here. We'll get into more of like why this is here down the road, but it's like a notation thing for now, so you have to have that. All right, and then add 1 to the exponent. So add 2 over 2. So you get x to the negative 1 half divided by, divided by negative 1 half plus c. clean that up. That's negative 2, and then I'm going to send x to the 1/2 down to the bottom, plus c. For this one, now here, so this is 9x squared, right? 1 over 9x squared. You can pull the 1/9 out in front of the integral. You don't have to do that, but then it's a little bit nicer to look at, I think. It's not as confusing. This is 1/9 times x to the negative 2. So I'm just going to pull the 1/9 out in front. So I'm really saying, all right, I've got 1/9. What do I get when I integrate this? So this is x to the negative 1 divided by negative 1 because I added 1 to my exponent. Plus c goes on the end. It doesn't have to go in parentheses. And then clean that up. So the x gets sent down to the denominator. And so this is really just 1/9 times negative 1 over 9x plus c. For these problems, I left my checking work over here because I just didn't want to extend the video. So it says find the indefinite integral and check the result by differentiation. So you're not going to have to check on your AP test, but this is just trying to point out to you that, like, hey, you can check your answers. If you find yourself with extra time, or if you're in a multiple choice problem, sometimes instead of integrating, you might want to just take derivatives of the answers and see if you get the original problem. So anyway, let's rewrite this to begin with. I want to get these in terms of exponents. So this is the integral of x to the 1/2 plus 1/2 x to the negative 1/2 dx. You technically should have parentheses around this. It's this function getting multiplied by a little tiny change in x dx. Now I'm going to take the integral. So add 1 to my exponents. So 1/2 plus 1 is x to the 3/2 divided by that new exponent, plus 1/2 times, add 1 to negative 1/2, you get x to the positive 1/2 divided by positive 1/2 plus c. Clean this up. So this is really 2/3 times x to the 3/2. And then what's this going to be? 1/2 times 2, so just 1. So plus x to the 1/2 plus c. That's my final answer for the antiderivative. And then I can check that work by saying, okay, take the derivative of the answer you just got, and that derivative should equal the integrand, which it does. For 31, again, I got my check work down here, but let's work on this a bit. So this is y to the 1/2 times y squared. Your exponent rules say you need to add those exponents. So y to the 2.5 or y to the 5/2 is how we need to write it. dy, because that's the variable, it's not dx. That matters. If you write dx, that's wrong. Add 1 to your exponent. So add 2 over 2, and you get y to the 7/2 divided by 7/2 plus c. And then we clean that up. That's 2/7 times y to the 7/2 plus c. So that's my answer. Check my answer by saying, all right, turn around and take the derivative with respect to y of that result you just got. The derivative of the antiderivative should come out to the original function that we had in the integrand. So yeah, so that does come out to y squared times y to the 1/2, which is what I had here. And this is on here not because it's difficult, but it just kind of looks weird when we're first learning about this. So remember, there is a 1 right here, if that helps you. Okay, so right now this is like 1x to the 0. So add 1 to your exponent, divide by 1. So yeah, the integral of dx is just x plus c. Take the derivative of x plus c, you get 1 plus 0. And yeah, that is what we have in our integrands there. Okay, the graph of the derivative function is given. Sketch the graphs of two functions that have the given derivative. Oh, I guess I might not have sketched the graph in my answer. I just gave the equation, sorry. So sketch the graphs. Okay. First of all, let's write our f prime equation. F prime of x is a horizontal line. It looks like it's going through 4, so it's equal to 4. So there's more than one correct answer here. What we're trying to say is, all right, the integral of f prime of x dx, that's equal to f of x plus c, right? The integral of the derivative, those operations cancel each other out. You're left with the function itself. So the integral of 4 dx would equal 4x plus c. All right. And then, so what are they saying? Come up with two functions. So one function could just be, okay, f of x is just 4x. So I guess I didn't sketch this graph, so I'll do that now. If I go, let's see, slope of 4. So if I go, let's see, up 4 over 1, I'm just going to roughly sketch this in. Something like that. So there's a possibility. That could be a possible f. Another possibility is f of x equals 4x plus any number. So I think I said plus 1 on my answer key. So same thing, but just like bump things up a bit. So it could be this, it could be anything, as long as you're having 4x plus or minus any value. So these are two examples of what f of x could be. This could be plus 1 million if I wanted to, or it could be minus 3/4 or so. It does not matter. Okay. All right. And then for number 46, same idea. Let's write the f prime equation first. This is a line with a slope of 1. Its y-intercept is 0. So its equation would just be f prime of x just equals x. You do have to pay attention. Sometimes they'll give us something more exciting with a different slope and a different y-intercept. So here's f prime x equals x. Again, the integral of f prime of x dx will equal f of x plus c. The integral of the derivative of f of x, those operations are inverses. They cancel each other out. So the integral of x dx will equal x squared over 2 plus c. So f of x can be any vertical shift of the x squared over 2 graph. So it could just be x squared over 2. It could be x squared over 2 minus 1, plus 1, plus 10,000, minus 0.0001, whatever. If I'm supposed to sketch a couple of those, I'm really not too worried about the sketch, but let's see. This is like 0, 0. Instead of 1, 1, it'd be 1, 1/2. Instead of 2, 4, it'd be 2, 2. So here's one example of what f could be. Maybe I shift that down 1. Could be that. Oh, I missed my points, but you get the idea. All right, and then the true or false section. I left my answers up here. I'll just kind of talk through these. Each antiderivative of an nth degree polynomial, so it has to be polynomial, is an n plus 1th degree polynomial function. So that has to be true, because if it's polynomial, that means you have x to some sort of n degree. And yeah, the answer is going to be x to the n plus 1 over n plus 1 plus c. So that's still polynomial. There's no way it's not going to be. You're not subtracting exponents, so you can't get negative exponents out of that. 91, if p of x is a polynomial function, then p has exactly one antiderivative whose graph contains the origin. So that's also true. Now this is not, obviously this is one type of polynomial, but let's say that this is an example of the antiderivative and it goes through 0, 0. So remember, the plus c is a vertical shift. So any vertical shift of this graph won't produce another point that hits 0, 0. So yeah, so there's exactly one that's going to go through 0, 0, but everything else, every other vertical shift will be something beyond that. 92 is also true. So if antiderivatives f of x and g of x, if those are antiderivatives of f of x, then they must be vertical shifts of each other. That's what that's saying. F of x must be g of x just plus some sort of c value, whether it's up c or down c. That's true. 93 is also true. So if f prime of x equals g of x, then the integral of g of x equals f of x plus c. So I did some work over here. Okay, so the integral of g of x dx, I just swapped out. They said g of x is equal to f prime, so that's what I did there. And I did that on the previous two problems. The antiderivative of the derivative of f of x will leave you with f of x plus c. So that's true. 94 is false. Just like, remember when we take derivatives of f times g, we can't just say, oh, that's f prime times g prime. There's like a whole rule for that, a product rule. We haven't covered this yet, but there is a product rule for integrals. It's called U substitution. So that's something we'll do later. But yeah, right now, that's not true. If we see a product, it's going to have to be something that it's either the derivative of something we already know, like trig, or it's something we can simplify. And then 95, the antiderivative of f of x is unique. Unique means there's only one answer, and that's not true because of the plus c. The plus c means that the antiderivative, the general solution to f prime of x, it's just f of x plus c. It's got infinitely many solutions. The unique solution is if they say the antiderivative when f of x goes through, when they give you a specific point, that is a unique solution. But otherwise, it's not. Okay, that finishes this homework. Tomorrow we will work on homework number 20.